Hi, this is Dr. Carl Goldkamp. If you're interested in learning about the ketogenic diet like I was, to save my own life, then this is probably the podcast for you. 8 years ago, I knew nothing about it. 6 years ago, it saved my life. 3 years ago, I started researching and talking with some of the authorities in the field and attending medical conferences about this to understand why and how keto so dramatically changed my and my wife's Judy's lives. The purpose of this podcast is to share our journey of discoveries with you in understanding how keto is so effective in improving so many different conditions, from obesity, epilepsy, diabetes, infertility, MS, Alzheimer's, heart disease, to name a few. So take a step away from all the hype you've probably heard and roll up your sleeves with me and join me weekly to explore this living miracle that anyone can access. We'll talk science, we'll talk food. We'll explore its history and evolution to today, which is that the sheer wonder of the ketogenic way of eating has changed untold number of lives, unlike anything before it. And in case I forget to mention it, please join our Facebook group, Keto Naturopath. Welcome back to another episode of the Keto Naturopath. I'm Dr. Carl Goldkamp. Today I want to go further with the idea of what we do with this genome information that we have. I've certainly been using it probably for the better part of nearly 20 years now. Let's say starting in 2003, so that's really 17 years. Though we had an inkling of what some of this information would yield and how to use it probably 5 or 10 years before when I was in medical school. That is that we started to hear about the value of homocysteine. So you'll remember that I've covered on previous podcasts, we talked about Kilmer-McCulley, the MD, the researcher MD, he didn't see patients, that did the work of sort of excavating the information on case studies that have pre-existed him on various genetic abnormalities. And so from his work, which is the better part of 20 years, from the 60s and 70s and into the 80s, that he determined we're going to get into that later, but he determined that there are 3 pathways that lead to a thing called elevated homocysteine, and that has certain problems. Okay, then. So what's that relevant for everything? Well, today, you and I live in the era of you can go to 23andMe or you can pick your company, and they are going to give you a modest report or a long report, like I've talked about in past podcasts, of all this information. So how do you use all this information? Are you going to take it and, with a flashlight at night under your covers at night, look at each information on your particular mutation, the singular SNP, singular nucleotide polymorphism? It's a mutation. Some are problematic and some are not problematic. Are you going to spend all that time? No, I don't think you are. And if you were, it's going to be basically a paralysis of, oh my gosh, what do I do with this information? I didn't know I had this risk for that or risk for this or potential problem if I don't eat that, but I should be eating this. And I really like that. So it really, I find it's almost an inappropriate amount of information to smother somebody with. It really, last thing we need in today, this is now of July of 2020, we're in COVID, going into second lockdown, people think that all we need is one more stressor, right? So you can say, oh, well, I can just look for these SNPs. I'm just going to evaluate it for what I can do with my immune system, make my immune system better and seeing where it's deficient from all this. All those are good logical possibilities, but it's much more complicated. And how I got into this was, first I learned about homocysteine in medical school, and I never quite understood it. It was kind of a new concept. It was hitting the presses relative to that point. And I knew nothing about the ketogenic diet. That didn't come up in med school at all. And so I'm a naturopath, so that's probably one of the reasons. Okay, so when you start practicing, you start doing a lot of labs on people. You're doing labs on a lot of people, not a lot of labs on any one person. So you get to be very lab heavy. I mean, this is just kind of the way we people. That's pretty much the way you start. You do a lot of labs, get very comfortable with labs. And I mentioned how I had read about and started testing for MTHFR. Now, that was pretty novel back in 2003. It's not very novel now. And I think it's become way over publicized and it's become way over emphasized to the point that people worry about it. One gene in the context of all the genes you have, or one mutation, is what they're looking at. They're not just looking at the gene. And so I did that. It had to do with autistic kids on the spectrum. And so I was homozygous for the worst you could have. So therefore, that has to do with, it's an impediment. It slows down on a particular pathway your ability to methylate B12 primarily. However, there are other pathways that kind of like workarounds, as we call that now. That the biggest highway was blocked. So if you have MTHFR homozygous for C677T, you have a highway that is blocked. Okay, now you look for the off-roads that can kind of compensate for that. Or you possibly could look at your diet and see if there are things you could do that way. Now, I want to pause for a second. We are so flush with this information about all these SNPs that we forget to realize that many generations before we got into processed foods and a polluted world that we live in today, that they lived just fine. These mutations evolved for a reason. And especially when a mutation is a popular mutation, so hence it's called a polymorphism, something that's pretty common. They don't even call it a mutation, really, even though that's what it is. It's so common, there's a lot of people that have this. So a lot of people are not dying because they have it, but it does present a slight problem. However, go back a couple hundred years, this same mutation that existed in these same ancestors of these people did not present a problem because their diet was different. Not hugely different. We're assuming that it was, at least I'm assuming, that it was very much high protein and moderate fat, and the fats were the appropriate fats. They came from real food. So the fats would be the fats in animal meat and fish, and probably if you were Mediterranean, then it would have been olive oil. Or if you were in Asia, it would have been palm oil, even though palm oil started in North Africa. But it's been in Asia for 400 years. Okay, then. So these are the things that your diet would have defaulted to, and you would have gotten by just fine. And also it would have been, you probably didn't eat and have food anytime you wanted to have food. So these are modern conveniences or inconveniences, depending how you look at it. So the point of this particular podcast is the application of Genome can benefit you. So my belief is, in coming through my experience of starting off one gene at a time back in the early 2000s and sort of building up this repertoire of ordering these mutations, I should say, these SNPs. I could order them at request, or wherever, LabCorp and who's ever in your area. And so started to get some experience to see, yes, I saw some correlations in some people, and others I didn't see the correlation, but if they had, when I had, and starting, let's say that first gene that I was all excited about, I would start, giving them methylated folate, or I would give them what they call methylating factors, and various supplement companies would have pretty much the same set of factors. Some people came back and said, wow, I've really noticed a difference. It could be a difference in their calmness. It could be a difference in even their sex life. And yet others, it didn't affect them. In fact, it might have made some of their issues worse. And it's really hard, by the way, to pull out this one thing that you told or gave a person to do. Did they do it consistently? And what else were they doing in their life, and so on? So there's a little hearsay when patients report to physicians, right? There's that conversation that can be shaved of a degree of truth or not, depending on the person that you get to know. Okay. So I was first put on to the idea of methylation is a big deal. So now MTHFR is just one, it's well known, and there's a lot of research on it. And it's primarily due to Dr. Kilmer McCulley, that, he came up gradually in his regression over 20 years that there are 3 different pathways that can really be a problem to have a thing called hyperhomocysteemia. Hyper being elevated, homocysteine being a specific protein compound. Urea means you find it in your urine. So homocysteinemia, you find it in your blood. Urea, you find it in your urine. If you have hyperhomocysteinuria, that's pretty severe. And what he found, and I mentioned this in past podcasts, what he found is you actually had a hyperaging. So he found a number of presentations, and these cells slides are still preserved. So he could go back and look at the tissues that were taken from these individuals that had hyperhomocysteinuria. And he found they had hyperaging, just like if it was elevated, very elevated cholesterol. So he came up with the theory that it's not about cholesterol, elevated cholesterol, it's about elevated homocysteine. And he changed the world. And that was a thing for the better part of subsequent 2 decades, 2000 to pretty much up to the present. People still do the test of homocysteine, which I think is valuable to do, but they're not, the general opinion is that it's not as tightly associated with cholesterol, and it's not the only bad guy in the room. There's other things you have to look at, and that's how medicine is. You don't just look at one thing. Okay, unless it's a severe genetic problem, and then that's the way it goes. Okay, so here we have, he was the first to look at genome, even though he didn't have it all mapped out. He had some of these things mapped out, and he kind of had to map it out himself from what they knew, that there were 3 pathways to have a problem. It wasn't just MTHFR. That was kind of the more common way of getting a problem. And this problem would lead to elevated homocysteine. Okay, that's something you can measure in the blood or in the urine. So that's where we set. And that's kind of where we're sitting now, is it's at this intersection that has to do with the methylation cycle. Once you've heard that word before, it connects. It's an intersection. And it connects to production of glutathione, which is the biggest antioxidant, the most effective antioxidant in the body. And if you can't produce enough glutathione, you're going to be vulnerable unless your diet is such that it's a good quality diet and it compensates. And that's how the world worked before. The world worked that our diet had all these supplements in it. They didn't have to take supplements, and they lived just fine, other than war and the plague and such. And so there was longevity before us. Yes, nutrition got better, but it was inherent in the food, and these mutations came out because there's so many of these, we're not going to call them supplements, these nutrients in the food, that it wasn't that critical that one thing be missing was going to be a problem. Well, now, fast forward, we're in the era of primarily processed food, highly refined foods. We think all that gives us a leg up so it's less potential of contamination, bacterial contamination and so on and so forth. So we think the processed food, this is how it got started. Anyway. So now we're all about processed food and hyper refined, so we have certain deficiencies. So what I wanted to talk a little bit about is like, how do I apply this? I definitely look at this whole intersection, I'm calling it, of methylation. I don't just look at MTHFR. I don't just look at, and there's 2 other SNPs that I look at as well, but I look at that on a genome level. But I also look at their blood work. Does their blood work show elevation in homocysteine? Does it show an elevation in inflammatory markers? So that has to be part of the reality. I can't just base a prescription on their genes, because those genes existed long before that individual, probably identical to them. It's the question of these genes in the context of what world? What are they eating? And then you could say, what are they breathing? What are they drinking? The quality of the water, quality of the air. Those are generally less of an issue. Your primary mode of pollution, if you will, of contamination is through the food that you eat. That's known. It's not hearsay. It's the food. It's the pollution, if you will, or the deficiencies that come in. So I thought it would be interesting to talk a little bit about some of these past studies briefly, just by reading titles and so on, is that homocysteine, there's a whole link I could, or graph I could show you. This, it would just be confusing. But the point is, homocysteine is really a couple steps away from this thing called methionine, another amino acid. Methionine primarily comes from meat. Okay, we talked about methionine and glycine as a ratio. Glycine comes primarily from cartilage, if well, but bone and cartilage, and therefore things like bone broth are high glycine, collagen is high glycine, but meat, so I'm speaking, when I say meat, I mean poultry, dairy, pigs, sheep, fish, all that meat, muscle, we'll call it muscle. All that muscle is high in methionine. So they did various experiments to create a methionine deficient diet. So they needed to have a diet deficient in methionine to see how that would affect various things. So how can you create a easy to replicate methionine deficient diet? Well, for a methionine deficient diet, all I have to do is eat soy. So you eat all the tofu in the world you like. And I was once a big tofu eater, by the way. Back in the day, I actually went to school at the University of Tokyo for a while, and I taught English there way back in a past life. So you got into tofu, put it that way. Got into all their culinary. What this is that it's really fascinating. I'm just going to read you a few of these things because this is the point of what I'm saying about methionine comes from meat, methionine, especially with all the anti-meat, is that you can get a methionine deficient diet, and that's going to set you up for a lot of problems. It's going to set you up for a lot of inflammation. It's going to set you up for a lot of, well, let's just read some of these titles. 2010, methionine deficient diet induces, all right, downregulation is cystathione beta synthase. What does that mean? It just means it's a step away, and that's the precursor for glutathione. So it simply says, well, if you don't eat enough methionine, you're not going to be making very much glutathione, and then consequently, you're going to have all the problems of not having enough being able to make enough antioxidant to quell all the oxidation your body has to use for its own defenses. Breathing, by the way, is an oxidative. Oxygen, you breathe oxygen, it's oxidative, to be obvious. All right, the effect of methionine deficiency on the utilization of energy by the chick. This is interesting. The wide use of soybean on meal, it says on meal, as a major source of protein in animal nutrition, and its moderate deficiency in sulfur amino acids has led to extensive studies. The work is interpreted to show that chicks overeat when fed a diet slightly deficient in methionine. Now let's pause on that. You can say, well, maybe chicks aren't like us. But guess what? All that we know about any of these things, it's research that either was done on rats, on mice, or chicks. And this is where we get the information. So most of medicine came from that information, didn't come from humans so much. So think of how many people overeat. So think of all the people that, where would that? If you're overeating, let's say that you would probably be, what isn't, we can get into neurotransmitters, we can get into all that. I'm not going to go there now, but I'm saying this was in chicks. Does it translate for humans? You bet. Being methionine deficiency will cause you to overeat, among other things. It's not that black or white. But isn't that interesting? So when you try to have processed foods, which is a lot cheaper to make things from soy than it is from meat, and if you end up being methionine deficient over time, you'll just keep munching away. Part of that is logical. If you're deficient in something, you're going to keep on eating to get more of that thing that you're, find other foods. So that's kind of a natural. If you don't get enough, you want more. If you don't get enough methionine, you want more of this thing that actually didn't have methionine in it, so it didn't help your situation. But that reaction is pretty common. All right, on to the next. Appetite and growth rate selection, a methionine deficient diet. It just affected growth. Yeah, too complicated, but that was from 1965. It affected growth in what animals are they using? I believe that one was mice as well. Okay, here's another one coming up. Let me see. Oh, you're going to love this one. This is, what's the date first? All right, 2015. A methionine deficient diet enhances adipose tissues, lipid metabolism, and alters antioxidant pathway in young growing pigs. Okay, there wasn't that many big words in there, but I'll tell you what it means. It basically means you're going to put on a lot of fat. So in pigs, we're no longer rats, we're now in pigs, and they gave them a methionine deficient diet. And by the way, pigs are actually pretty close to us genetically. And before That's where we used to get our cortisol, by the way. They used to extract it from pigs before they learned how to make it synthetically. And same for insulin. It was dependent on pigs. So we had pig insulin after the original dog insulin from Dr. Banting up in Canada in the early 20s. Okay, so being methionine in rodents, so it said methionine is a rate-limiting amino acid for protein synthesis. But contrary to rodents, where a dietary methionine deficiency led to lower adiposity, fat, it led to an increase in lipid in pigs. So now you're looking at certain deficiencies drive compensatory behaviors, right? Both biochemically and in our own sense of got to have more, got to get our methionine. Pretty interesting. So back to, what are we talking about? Genome. If you look at diet overlaid with genome, you go, homocysteine can come from a number of places. If we're looking for an elevated homocysteine and all the problems that carries. Was it blocked? It couldn't be converted down into glutathione and a few other downstream things. Okay, you look at that particular mutation. Or was it not being able to convert back to methionine? And you check those. So it was out of the work of Kilmer Mercalli that you had these three pathways. So this is what I check when I look at, for instance, people in our program that go through and I check that out. That's really important. If you can, and these people that have these particular pathway problems, and there's people that don't have these pathway problems as well. These people that have these pathway problems and have really elevated, jacked up homocysteine, that, this is easy to treat. So how would you treat it? One is you would talk about diet. You would check saying, all right, with these people with this problem, what is their actual diet like? Okay, it's crap. Well, you do a little education around, please don't eat crap. These are the things I would advise you to eat. And this is why this is your motivation, because you have these particular labs and these particular genetic problems that you might want to change your diet. Some people are smart enough to do that, at least while they're in our program. They're going to be pretty much held accountable to doing some of these things. And the other is you can then supplement with called B vitamins, some more specific than others, to basically supplement the pathway that is problematic. You're doing these little workarounds. And so when you put these two together, you can pretty quickly drop their homocysteine. You can get their glutathione back up. So they're a happy camper. And so whatever reason they actually came into, or aches and pains they had in their life, and if we're talking about a patient, the reason they came back into you, you've now improved their life a lot. They can sleep better. I haven't even gone to the neurotransmitter aspect of the methylation and the folate acid cycle. And this is exactly what we're talking about, trying to keep it on a certain level. It's like, so if people have neurotransmitters problems and other things, and you look at this and you go, wow, you have these particular mutations. These are treatable. By the way, if you went back in time and had the diet that your ancestors had, you wouldn't need to be treated by me, but they're having their diet and eating their crap, and they have these deficiencies. Therefore, that's a bad combination. If you have these three, if you have this intersection for a problem, then you are at greater risk for certainly all sorts of for B12 deficiency for one, folate deficiency for another. That then puts you at risk for a lot of other things, what they call macrocytic and pernicious anemia. You also can be at risk for a bipolar, schizophrenia, and severe depression. So these are all a collection of problems that can come out of this intersection, these particular three pathways. So isn't that interesting? So this is the way you can actually apply using one's genome and look for these things. So now it gets to be much more complicated than that. People are much more educated and they go, well, I have this SNP. And another SNP that comes up a lot is one that's called COMT. And that does have to do with methylating estrogen. And so women are generally much more aware of this than men, as is generally the case in a lot of self-awareness issues. So, but technically they're more, they look into estrogen metabolism, especially when they're premenopausal and they're still cycling. And so when they don't metabolize their estrogen well, they'll have probably severe PMS. They may be severely depressed and so on and so forth. And so they'll check into it. So COMT is, people go, I'm an undermethylator. I have a slow COMT. So it stands for catechol methyl. Here are the methyl transferase. And so do you really care? No, but there's methyl in there. It means that they can't methylate their estrogen well enough to get it excreted, get it broken down, get it detox. So it tends to build up and go down another pathway. So let me just read you something that, what I'm trying to bring up here is that often there's a lot of fear around one little mutation. And considering there's a gazillion, there's lots, more or less, a gazillion number of mutations, the first question you need to ask is, which ones are really relevant and which ones can I intervene on in terms of diet or supplementation and behavior that would improve these situations. Those are the kind of the relevant ones, not just you have this long, long list and most you can't do anything about. And that's how you would choose a company to help you evaluate that. What is the most relevant, actionable list that I can use without suddenly smothering my life in a kind of stasis of inactivity because you're just so stressed with all that information. So anyways, COMT is another one. And so there again, we do a hormone panel, we do the blood panel, we get a lot of people that are slow estrogen methylators, so they have this slow COMT. But if these people also have this intersection of methylation factors, that's pretty easy to treat. In my view, it's pretty easy to treat. Certainly since Kevin McCauley, laid it all out for us back in the 90s. And so you can proceed with either supplementation, dietary change, and that should really bring these things back. So if one is a slow COMT estrogen metabolizer, I don't see it as a big deal. I see it initially as, okay, here you have that risk. Do you have the symptoms of being a undermethylator of that particular estrogen? So let me just read you I'm not going to read you the article, but I'm going to read you the headlines and little pieces that came into Psychology Today. Psychology Today is kind of evolved into this funny sort of sometimes true and sometimes not. Sometimes they need an article. It's kind of like WebMD. It's kind of like Medical Express. They all want something somewhat sensational. So the drive, like with journalism in general, unfortunately, bad journalism, I should say, is a drive to be somewhat sensational and to exaggerate one small aspect of the truth and not to mention the larger context. Okay, so I'm going to find this and come back and just sort of read you. And the point is, these genes are floated by you by saying, oh, you should go look at this one. You may have this one and it could change your life. And remember that, let's say you are one of these people and you do find you have this particular genetic mutation. So how did your ancestors get by? Okay. So these are the lesser. This is not like BRCA1 or BRCA2 or certain genes that are high value. They do have a high propensity for causing problems. There's not many of those, and those are well identified. And your family history would speak to that already. So, okay, so here's that article in Psychology Today that came out in January 2020. It goes, how does the COMT gene, or what is the COMT gene, and how does it affect your health? First thing is, it's analyzed by a PhD, which means we're going to get a lot of information and probably no experience. And so that's the problem. She could be a smart person and it happens to be a woman. Well, it's an estrogen story, isn't it? And so I like when you have the information with somebody's experience and so on and so forth. So it goes on to saying, we are going to talk about how estrogen is detoxified, and that's a good thing, and that's right. But it goes on and explains what it does, more or less what I've just told you. Few other related genome SNPs that I've talked to you about. And it basically says, because COMT is a methylation gene, just to have more B vitamins. That's sort of the first okay take. Magnesium, SAMe, that's a part of the cycle. It's another part of the methylation cycle. And it goes on and says, in addition, you shouldn't have these foods, you should have these foods. Other things that keep your eye on are now another list of genes. And then it says, here's the part I want to get to. It gives you the impression that this is all controllable. At the same time, it's like, here's the supplements you could take, and it goes on and on. It's a laundry list, and this is just this one mutation that, yes, in a context may cause certain problems, but for most people, it's not a problem at all, given a balanced diet. So maybe I haven't supported that enough here. It's just that I want to plow through this whole thing, but I'm saying that this is covered in a pretty well-read journal. This is the online version of it. And it's saying, don't have alcohol, don't limit your caffeine. All these make good sense. Make sure you get enough sleep. Make sure you don't have contaminants in your topicals, parabens. Watch out for soy. Here it's saying watch out for soy. I brought up soy before because it was methionine deficient. Here it's saying watch out for soy because it's a phytoestrogen. Phytoestrogen is not identical to an estrogen. They have a weak estrogenic connection with your estrogen receptors. And anyways, this is where we're going here on that particular. So my point is there's some good things in the article, but it sort of presents this overwhelming thing like, oh my gosh, I should go find out if I have this particular issue. Men should also look into this as well. I mean, men also have estrogen problems. They have other issues, but it's certainly that. So that's just an example of another popular gene to look at. So big picture. In the application of looking at what the heck are you going to do with this genetic information you got from, let's say, 23andMe or that company you spent anywhere from $500 to a couple $1,000 or $300 to do it, and you got this report back and it tells you should change. I would say back off, chill, just catch your breath, chill. But I do look at, there is a whole biochemistry chart in front of me that you get to see the interplay because, as I've already told you about, methionine that comes from meat can affect homocysteine, and if you can process it or not, depending on your diet primarily, you may have a glutathione problem. And before glutathione, you may have a cysteine problem. Talked about that a little bit. But also neurotransmitters come into a lot. So there's a lot of these things feed in, but you can kind of correct this by looking at it as a big picture and not getting too caught up in the little pieces as it goes. It is very fascinating. I mean, clearly it pulled me in 20 years ago, and I still like to look at this. When people come in and I look at their, feast on their genome report, and you go through and said, this is interesting. And I know who the person is, and I have their other labs and their hormones and micronutrient deficiencies. And you go, wow, you can really change this person's life by making sure that they have the appropriate nutrients, that they are counseled on not eating the garbage they're more than likely eating, or let them know why certain foods are garbage that they thought were not garbage. It's kind of a common sense, but not everybody knows that, by the way. And then it really takes the stress off. I mean, it comes right down into, how's their moods, the serotonin, the melatonin, the tryptophan, even goes into neurotransmitters that are made or not made after sex. Why are some people not satisfied? Well, it basically has to do with these pathways, or dopamine and epinephrine and so on. So I wanted to give you a sense that this information is not just vast and huge and overwhelming, but it does have an application. It is actionable, and it can make huge difference. And so in my pulling myself forward in time from 2003 on up and getting better and better and a little more comprehensive about using this, I would find that I would be very specific with certain patients if they had this cluster of mutations. And I would look for a few other clusters. I could have used a couple other examples as well, but I find these are the most appropriate. I find that the research gets on very thin ice when we start saying, oh, you should be in a carb diet, you should be in a protein diet. There is not enough information about that. That is just such garbage. And that's where I think this cottage industry of genome analysis has gone too far. They really just want to sell you a certain supplement. So I'm hoping to shoehorn some common sense and into how you would use this in your interest of using this. So let's say you were a cancer patient. let's say you were a cancer patient, I would definitely go through all this. And so now I have a context that you're different than everybody else, and also the kind of cancer that you have. So I would, and now when they really do cancer, hopefully if you had cancer, you would have seen an oncologist that took, and when you have a cancer, it starts making different genes. So it's a different set of genes. It's not these genes we're looking at. And so they tend to stamp, tattoo in essence, that cancer with this a certain kind of genetic mutations that the cancer itself has created. Now, Tom Siegfried, as you remember, he was one treating cancer as a metabolic illness. And so he was talking about dropping the sugar, right? Dropping the glucose, increasing the ketones, which is basically having a very low carb or no carb diet, and having a high fat so that you were boxed in. He wasn't worried about you weight loss or not, but making sure that you were burning ketones. And he had an example of a patient who did very well, but they really needed to take it on as a lifestyle and not go, I'm just going to do this while I can get over my cancer and then go back to eating garbage. It doesn't work that way. So that's where the cancer thing is. And so I wanted to bring up a point in our Facebook group that we had. A woman was asking about, I forgot the initial question was, but she started keto and she's feeling nauseous and so on and so forth and had pain in her left side. So we said, go see your doctor. So, but when I got into her case a little bit, she's on Prilosec, which is a proton pump inhibitor, which means it turns off your stomach acid. So while she was doing this, it says you're getting heartburn, and her physician gave her Prilosec. So now this drug has turned off its stomach acid. So now consequently, your stomach is not pushing through this high acid stuff into the top of your small intestine. So if what comes out of the stomach is not high acid and not acidic enough, we're talking 1 and 2 in terms of a pH, your digestive enzymes from your pancreas won't be triggered. Things like cholecystokinin and so on and so forth. So they're not triggered. So yes, now you've created a whole downline sequence of problems. Not only that, you will have induced a B12 deficiency. So now let me say this is this person. Let's pretend this person this comment came up. She's now self-inducing, because she's following directions from her physician, a B12 deficiency. First, she's going to start getting tired because she doesn't get enough folic acid, because stomach acid doesn't secrete intrinsic factor as well, and therefore that's why you don't get your B12 absorbed. All right, she's getting tired. But let's pretend that has this constellation. At least she has my genes, MTHFR, and she has my mutation, plus throw in a few others. So she now is not just at risk for B12 deficiency, which is a certainty. She's now at risk for severe depression, fatigue, severe depression, perhaps bipolar, perhaps schizophrenia, given that set of genes. And so when you add in a medication that undoubtedly would have been taken for month after month after month, her B12 deficiency followed by a folic acid deficiency would have gotten greater and greater, to the point that you could see it in a blood work that she's deficient. But she was now a set of the population that was more predisposed to a greater vulnerability, that she could go off the rails. She could have a big problem just from this medication. So that's how you use this information. There's certain people that have a greater propensity to a certain vulnerability that you just have to be careful for. So therefore, they wouldn't be on certain medications. Hopefully they'd be counseled about nutrition, and then you could supplement them. And that would probably keep you out of the woods and may even just clear up the problems. But when that's not done and medications are given without understanding that, there is a bigger problem. And I've had that problem with patients I've seen. Okay, I wanted to end on that note because I wanted to make this a real thing, not an abstract tonnage of academic information, but something that is usable. It's fascinating. It's a little bit narcissistic, if you ask me. People get these reports and they go, oh my gosh, this is why I sleep on my left side or my right side. Maybe yes, maybe no, but there's a bigger picture that can be gleaned and used to have you have a better life. Okay? So until next time, this is Dr. Carl Goldkamp. Bye-bye. Hi, this is Dr. Goldcamp. I just wanted to encourage you to send in your questions to Dr. Goldcamp at ketonaturopath.com. Many of you have, and so what I've done with these questions that gotten back to most of the people I email, but some of the questions that were so good, and if they were overlapping to other questions, I would combine them and try to put that into the topic of a podcast, either via one of the micro topics that are covered in an interview. As you know, we cover a lot of topics in any given interview, or some of my own sort of reporting, if you will, on some of these issues. So please keep the questions coming. Feel free to send in an email, and I will get back to you. One thing I want to say, a number of questions have come in which I've given this answer and the email didn't work. So just make sure that you're receiving at the same email that you sent it in. And I think that might have been the difficulty. So I look forward to your questions. I just wanted to make sure that you knew that I'm open to answer your questions. And I think this world of keto is not just black and white. You know, it's nice that it's simple, but it's not simple for some. I'm really trying to, go down as any of you who have listened to all my podcasts. We started way back when, history and evolution and epilepsy and so on and so forth. Now we're seeing some tremendous overlap in various mental disorders, such as schizophrenia or neurological disorders that are not just epilepsy. And also, just for people in losing weight, it's sometimes pretty complicated for them to engage in keto. And so they need some help. And so that's the whole point of, at least that's what I think I'm doing, is exploring the world of why are there other factors. And so in exploring some of those other factors, we've covered addiction, we've covered hormones, we've covered nutritional deficiencies, we've covered certain metabolic lab results, and we'll go further. We'll even get to more on genome and aspects. So these are all just contributions that make for an obstacle for some people to engage easily in the ketogenic diet. This is my belief, and these are the things that I've discovered. And I think other people have discovered some of these things, but not ever put them together. So stay listening, send in your questions, and I will definitely get back to you.